So, good morning, everyone, and welcome to today's lecture. We are dealing with relative motion, and we will try to wind up relative motion in one dimension in this class and move on to relative motion in two dimension as well. In the last class, we had seen what we had seen was velocity of separation and velocity of approach, and we had also seen how do you find out this velocity of separation or velocity of approach. If the distance is increasing, it is velocity of separation. If the distance is decreasing, it is velocity of approach. We had solved a couple of problems. There is one more type of problem that we need to solve, and this is the type of problem which is more likely to come in your NEET apart from the problem that we have done. So I will put this problem for you, and I hope that you are able to solve this. I'll give you 2 minutes to do this. The problem goes like this: a particle A is moving with a speed of 10 meters per second towards right. Particle B is moving with a speed of 10 meters towards right. Both the particles are moving 10 meters towards right. Then there is a particle C which is moving 10 meters per second towards left. The separation between A and B is 100 meters. It always remains 100 meters. So now this particle C is passing B at some point, and this is the point where it is crossing. At this point, it is crossing. The particle C is crossing particle B. After how much time? After this time, will this particle C cross or meet particle A? Give you 2 minutes. This question has been asked in a different way. The simpler version of this question would be B moving towards A with a speed of 10 meters per second, and they ask you when do A and B meet. But instead of asking you when A and B meet and reversing the velocity of B, they have put B like this, and instead of B, they have got C. Doesn't matter, the question remains same, and I'll give you 1 minute to think about it and tell me how you are going to do this one. I hope everyone is there in the class, right? The class has started, beta. I hope everyone is there. I've given you the first question. The first question is about two bodies, A and B, moving in the same direction with velocity 10 meters per second. Then a body C is crossing body B. At some time, you have to tell me when does it cross body A. I'll give you 5 minutes since we have just now come. We have dealt with velocity of separation and velocity of approach. In this question, it is velocity of approach or is it velocity of separation? Do you have the mic? Is this velocity of separation or is this velocity of approach? Are they approaching or are they getting separated? Remember, between A and B, it is neither velocity of separation nor velocity of approach. I'm asking between A and C. Between A and C, is it velocity of separation or is it velocity of approach? It is velocity of approach. I hope you understand this.
Sir, am I audible to you?
Yes, you're audible. Am I audible?
Yes, sir, you are audible.
Okay, so this is velocity of approach. Read the question. Take your time. Don't worry. Take your time. Read the question. Give me the answer. I'll wait. Yes, bacha, how do you get the answer? Any idea? The simple form is A is going to meet C or C is going to meet A. Now you first find the velocity of approach. What is the velocity of approach? This is plus 10. This is minus 10. Plus 10 minus minus 10. That will be equal to 20 meter per second. Yes or no? 20 meter per second is the velocity of approach. Do we get this? Yes or no? So both of these are approaching with a velocity of 10 meter per second. There is no acceleration. How you are going to do this? The total distance they have to cover is 100 meters. So the time that is required will be 100 divided by the velocity of approach. 100 divided by 20. So they will meet each other in 5 seconds. Do we understand this? Yes or no? Okay, so this is a simple question of velocity of approach. I hope everyone has got this. I'll give you 1 minute to note this down and then we'll move forward with the next type of questions. Are we done, bacha? Shall we move ahead? Or shall I wait? Okay. This is the next question. A and B, two balls are thrown vertically up. One is having velocity 5 meter per second. The second one is having velocity 10 meter per second. G is 10 meter per second square. What is the separation between them after one? Everything is okay, beta? I hear something. Everything is okay? Okay. You have 2 minutes to solve this. Do we need more time, beta, or shall I do it? Are you trying? Okay, I'll give you 1 more minute.
Sir, 5 meters.
5 meters is absolutely correct. Well done. How did you get 5 meters? That is correct. How did you get 5 meters? Yes, tell me.
VBA is equals to VB minus VA.
Okay.
VB 10 meter seconds. VA 5 seconds.
Okay, so we can find out velocity of A with respect to B. That will be velocity of A minus velocity of B. So it will be, both are up. So it will be 5 minus 10. Yes or no? So it is minus 5. Yes or no?
Yes, sir.
That is actually the initial velocity of A with respect to B. Initial velocity of A with respect to B. Initial velocity of A, initial velocity of B. They have been thrown in air, so they also have accelerations. So we find the acceleration of A with respect to B. That will be equal to acceleration of A minus acceleration of B. Now both are under gravity, so their accelerations are 0. Do we understand this? Since both are in gravity, their accelerations are same. Therefore, this part becomes 0. Do we understand this? Now, you just have to find out a distance. It is now from 1 to 2. It is motion in a straight line without acceleration. The velocity will remain same. It is always equal to minus 5. If I look from object B, it is minus 5. If I look from object A, it is plus 5. It is 5 in magnitude. And how much will be the distance? So you can find out the displacement of A with respect to B will be equal to initial velocity of A with respect to B into T plus half acceleration of A with respect to B into T square. But this term does not come. You understand why this term does not come? Because acceleration of A and B both are same. So you just multiply 5 with T and the answer will be 5 meters. Do we understand this? Yes or no? Well done. I really surprised. I always keep on telling this to those people, those students from JEE that NEET students are doing much better than what you are. Can we do this one now? This question does not come with a diagram, so it's better that I don't give you the diagram. I just give you the question. So here comes the question only. First, I gave you the diagram, then I've taken out the diagram from that question because diagram is not a part of the question. The question is like this. Now, in the previous question, both the balls were thrown up from ground. Now, one ball is thrown up from ground, another is thrown downwards from the top of a tower. A ball is thrown downward with a speed of 20 meters per second from the top of a tower or a building, 150 meter high, and simultaneously, same time, another ball is thrown vertically upward with a speed of 30 meters per second from the foot of the building. Find the time when the balls meet. 2 minutes you have. Yes, my dear friends, any answers? Is it so difficult? Huh? Shall I do it? Or you want more time? Shall I do it, bacha, for you? Or you want more time? Okay, I'll give you 1 more minute. Okay, I think you have taken a lot of time. Shall I? I will try to help you. How are we supposed to do this? So, if you want, you can draw a simple diagram. This is the simple diagram. Let us say this is your tower. This is A. You are throwing this ball vertically downwards with a speed of 20 meter per second. Then you have ball B. You are throwing it vertically upwards with a speed of 30 meters per second. We understand this, yes or no? Do we understand this, yes or no, beta? Okay. Now remember that this distance that they have to travel, the height of the tower is 150 meters. Now I can find velocity of A with respect to B or velocity of B with respect to A. Let me find velocity of B with respect to A. It is plus 30 minus velocity of A is minus 10. Yes or no? No, minus 20. Yes or no? So it becomes plus 50. Do we understand this? If I find the acceleration of B with respect to A, it will be 10 minus 10 and it will be equal to 0. Yes or no? Now, what they have to move, the displacement of B with respect to A, how much B has to move with respect to A? It is 150 meters. Yes or no? And there is no acceleration. So how much time it will take? Displacement is 150. Velocity is 50. They will meet after 3 seconds. You can see that there is no difference between this question, which I can call as question number 3, between this question, question number 3, between this question number 3, and this question number 1. There is absolutely no difference. The only difference is here they are moving like this. Here they are moving like this. but in both the cases, moving this or this, but in both the cases, they don't have any acceleration. Here the distance was 100 meters and the relative velocity was 20 meter per second, 100 meter, 20 meter per second. And you look at this question, now it is 150 meters, 150 meters and 50 meter per second. So in both the cases, whether they are moving like this or they are moving like this, in both the cases, there was no acceleration and it was pretty simple. Do we understand this? Okay, I'll give you 2 minutes to note this down. Once you note this down, please let me know so that I can move ahead.
Completed, sir.
Well done. Completed. That takes me to the next part. Just give me a minute. That takes me to the next part. Where is the next part? Yes, here. That takes me to the next part. And that is known as, what was the heading of this chapter? They are known as river problems. So we write the heading river problems. In 1D. Now, when this is river problems in 1D, these are also known as upstream, downstream problem. They are known as upstream, downstream problem. What do you mean by upstream, downstream? Do you know what do you mean by upstream? What do you mean by downstream? These are the terms that you might have heard. Suppose we have a river, and let us say this is my river, and this is how the river is flowing. This is how the river is flowing. The river flows, let us say, with a velocity u. So velocity of river flow is like this. Do we understand this? Yes or no? So river is flowing like this. These are the two banks of the river. Bank number A, river bank. Bank number 1. This is river bank number 2. Now this u is basically given as velocity of river or water with respect to ground. Do we understand this? So remember, this u is the velocity of the river with respect to ground. Now, if a person is swimming in this river or a boat is rowing in this river, it can, in first case, it can move like this along the direction of river flow, or it can move like this opposite to the direction of river flow. Do we understand this? So it can move in the same direction, the green direction. If it moves in the green direction, then it is known as it is moving. If it is moving in the green direction, then we, oops. What's happening here? Just give me a minute. Okay, let me continue with the class and I will talk to people after this. Okay, if they are moving in the green direction, I say that they are moving downstream. This is known as downstream. When I say downstream, they are moving with the direction of river flow. And if they are moving like this, opposite to the direction of river flow, I call it upstream. Do we understand upstream and downstream? Upstream and downstream. In both the cases, what is given to you normally is V. V. V is given to you. And when I say V, what do I mean by this V? With this V, I mean this is the velocity of man with respect to the river or water. So there are two things that is given to me. Point number one, I am given U, which is the velocity of river with respect to ground. Point number two, what we are given is V, velocity of man with respect to river. Do we understand this? These are the two things that is normally given to you. Now what happens when he's flowing downstream, when he's swimming downstream, his velocity with respect to ground becomes u plus v, yes or no? So in the downstream condition, when I'm going downstream, the velocity of man with respect to ground, so I write it like this, velocity of man with respect to ground becomes u plus v. Do we understand this? Both gets added up. If the river is flowing with 3 meter per second and I am flowing with 2 meter per second, my net velocity becomes 5 meter per second. Do we understand this? When the river is flowing up, when I am going upstream, river only flows in one direction. When I flow upstream, then my velocity of this man with respect to ground becomes v minus u. You can write this as not u plus v, you can write this as v plus u if you want to write it in that same order. So my velocity will get subtracted. If I am moving with velocity 3 meter per second and river is flowing with 2 meter per second, my net velocity becomes only 1 meter per second. Do we understand this? I'll give you 2 minutes to write this, draw this diagram, and then we will start with the question. Let me know once you are done, bacha. Once you are done, let me know so that I can move forward with some questions. Done? Okay. Then let us solve this question. I hope everyone has noted this. Question number 1. A river flows with velocity 2 meter per second, and a man can swim with a velocity 3 meter per second with respect to the river. How much time man takes to travel a distance of 10 meters if number A, he goes downstream, B, he swims upstream. So if he's swimming downstream, how much time will he take? If he swims upstream, how much time will he take? You'll get 2 minutes to solve this. Let me know if you have done this. Yes, bacha, do we have an answer? Shall I do it or you want time? Yes, bacha. I'll give you 1 more minute. Okay, I will do it. Then how are you supposed to do it? Anyone can help me? So when I'm moving upstream, or let me do it downstream. When I'm moving it downstream, what will be the net velocity? It will be 2 plus 3, yes or no? That will be equal to 5 meter per second. So how much time will it take to move a distance of 10 meters? 10 divided by 5, and the answer is 2 seconds. Do we understand this? Was it so difficult for you to get this? I thought that you will get it. Do we understand this? Yes or no? What will happen if I go upstream? Upstream, my velocity is 3. River will be -2. Moving against the river, it becomes 1 meter per second, my dear friends. So how much time I will take to move the same distance upstream? 10 by 1, it would be 10 seconds here. 10 seconds I will take. So you can see a difference between 2 seconds and 10 seconds. If you flow with the river flow, your velocity with the river gets added. If you move against the river flow, the velocity gets subtracted. Do we understand this? Yes or no? Everyone, now one question is for you, and I really sincerely hope that you can give me the answer to this one that will lock this topic once and for all. Let's see if you can do this one. Here is the question. Similar question we have done. This is another variation of the same question. A swimmer capable of swimming with velocity v relative to river jumps in a river flowing with a velocity u. He swims a distance d downstream and returns back. Find out the total time taken. What is the total time taken? So he jumps, he moves a distance d, and then comes back to his original position. How much time does it take? You have 2 minutes to solve and give me the answer. Yes, bacha, can I do it? Or you are going to do this for me? Yes or no? Or shall I do it? Okay. So again, he first goes downstream. So what is the velocity of him downstream? It will become v plus u. Yes or no? So how much time he will take downstream? The distance is d. D divided by v plus u. We understand this? Let us talk about the upstream. Velocity upstream will be v minus u. So time taken upstream will be d upon v minus u. I hope all of you understand this. Yes or no? Total time taken. If I call this as t, total time taken will be time taken to go up plus time taken to go down, downstream. We have calculated that before also. Now also we just need to add it. So what do you do? Time taken to go up is d upon v minus u. Time taken to go downstream is d upon v plus u. I hope all of you understand this. Now you need to simply add it up. Now you simply need to add it up by taking LCM. When you do this, you will get this 2 times dv upon v square minus u square. That is the time it will take, total time it will take to go up, to go downstream and then upstream. Do we understand this? Yes or no? No, yes. So in this lecture, what we have done, beta, if we have tried to cover your motion in one dimension, the relative motion in one dimension, and we have covered all the questions that could come. The next class, what we will do is we will cover motion, relative motion in 2 dimension on similar lines. I hope you have understood this. Any doubt? You can always come up to me. Let us call this a day, and I hope God helps you. Take care. Bye bye. Please note down what we have done. Everyone has noted this down? Take care. God bless you.